The beauty of this question lies in finding the points whose affixes are alpha and beta, and that too geometrically. But if we use coordinate geometry for finding the value of alpha and beta, that will be very lengthy, and the examiner doesn't expect the student to use coordinate geometry to do this question, because time is also a very important factor in this exam. And I also prefer to do the question of complex numbers using complex numbers only rather than converting the question in coordinate geometry. Geometrical ways are short and interesting both, but for using geometrical ways, all the concepts of this chapter should be crystal clear and known to you. In this question, it is told to us that for any complex numbers w equal to c plus id, let argument of w belongs to this interval where I is equal to under root minus 1. Let alpha and beta be real numbers such that for all complex numbers z satisfying this equation, the ordered pair xy lies on the circle this. Then which of the following statement is true? Beautiful question. And because of such beautiful questions, I enjoy solving the questions of JEE Advanced. Before solving this question, first I will tell you a very important concept which I am going to use in this question, and that is, suppose these are the two lines and this is the point P and this is the point A and this is the point B. Z1, Z2 and Z3, and suppose we have to find this angle. For finding this angle, first make two vectors starting at the point. These are PA and PB, and after this mark anti-clockwise direction in this angle, and then write theta is equal to argument of from where the angle is starting, that vector is to be written in the denominator, and the vector where the angle is ending, that vector is to be written in the numerator. That is, theta is equal to argument of z1 minus z3, z2 minus z3. You must be knowing, just like in vector algebra, AB vector is position vector of B minus position vector of A. Similarly, in complex numbers, AB vector means affix of B minus affix of A. That is, in simple language, I can say complex number of B minus complex number of the point A. This is a very important formula, and the extension of this formula is when instead of this point of intersection, 4 points A, B, C, D are known to you, but the explanation of this formula is not required here. Here this special formula is required, hence I have explained you this. Now I will do this question in two ways. In both the ways, complex numbers will be used. Another way in which we take the help of coordinate geometry, that is too much length, therefore I will not explain that way. Before discussing the solution of this question, first I will make you understand that argument of z minus z1 upon z minus z2 is equal to theta, where theta is not equal to 0 or pi. I will prove that locus of z is a circle. Why? See, I am also going to use the concept that in a circle angle in the same segment, that is these angles are always same, that is if A and B are fixed point, P is a point which varies in such a way that angle between PA and PB is fixed, then the point P will be surely moving on a circle. For the points on this part, angle will be fixed, and for the points on this part, angle will be also fixed, and that will be supplement of this angle. That is, if this is theta, angle in this part will be pi minus theta. All these things are known to you. And now I'm going to make you understand that if z1, z2 and theta are fixed, locus of z will be a part of circle. Roughly we say it's circle, but saying exactly it is a part of circle, and that too excluding endpoints of that part also. Suppose the line, this is the point A, this is the point B, this has a fx z1, this has a fx z2, and P is a variable point, and this equation can be written as argument of AP vector BP vector is equal to theta, and according to formula I just now told, this is BP vector, this is AP vector. Angle will start from BP vector and at AP vector and moving anti-clockwise. This angle will be theta, and because theta is constant means this angle is constant, that is this angle is constant, and because this angle is constant, therefore the locus of this point will have to be a circle, and that too only this part of the circle, not lower part, because in lower part the angle will be pi minus theta. Hence, whenever the angle is fixed, the locus of the point P will be a part of circle. And now to make it more clear, suppose it is given that argument of z minus 2 plus ci upon z minus 1 minus 2i is equal to say pi by 7, and suppose this is the point having fx 1 minus 2i, this is the point having fx 2 plus 3i, and z is the fx of a variable point, and suppose this point is A and this point is B, and suppose this is a point P, and this equation now can be written as argument of AP vector and BP vector is equal to pi by 7. Clearly this is AP vector, this is BP vector. According to the given equation, angle between BP and AP is fixed, and this angle is pi by 7. It will be starting from BP vector and going up to AP vector. This is pi by 7, and because the angle is fixed, this angle is also pi by 7, and because the angle is fixed, locus of this point will be a part of the circle. And one thing more is to be noted, and that is, if the angle is minus pi by 7, then the point P will not move on this part, then P will have to be moving on this part. And this is also very much clear that if the angle is acute, we always get major arc, and if the angle is obtuse, we get minor arc. And if by chance plus minus is given to you, then we'll be getting two major arcs, this and this. And again, for even more clarity, in the case of minus pi by 7, why the circle will be downward? Because according to formula we have to start from BP vector and go up to AP vector, and the direction is anti-clockwise if the angle is positive, and if the angle is negative, direction will have to be clockwise. And suppose the P point is here, angle, this is the BP vector, this is AP vector, and this angle in amount will be pi by 7, but because of negative angle, you can see very easily from BP to AP the direction should be clockwise. Here it is BP, here it is AP, this direction is clearly clockwise. That is why in the case of minus pi by 7, P point will have to be moving below. That is, whenever this angle is fixed, the locus of the point P will be a part of circle, and upper part or lower part, that depends upon the sign of that angle. And for those students who were not knowing this concept, I will say revise this chapter, because it is a very important part of this chapter of complex numbers. And keeping this formula in mind, first I write the given equation as argument of z minus alpha upon z minus beta equal to pi by 4. And for even more simplicity, I will prefer to write z1 for minus alpha and z2 for minus beta, because it is a bit inconvenient to write minus alpha again and again. Hence I am naming it as z1 and z2. Once z1 and z2 are known, alpha and beta will be just negative of these two. Now the given equation becomes argument of z minus z1 upon z minus z2 is equal to pi by 4. And now I write it as argument of AP vector BP vector is equal to pi by 4. It is clear that the locus of the point P will be a circle, and it is given that P lies on this circle, whose diagram will be having center minus 5 by 2 and 3 by 2. Minus 5 by 2, comma 3 by 2, that is somewhere of this type. P lies anywhere on this circle, and because Z lies anywhere on this circle, means P point lies anywhere on this circle, and according to this given equation, this angle will have to be pi by 4. And because it is given that Z1 and Z2 are real number, means I can say A and B have to lie on x-axis. But the beauty of this question lies here, that out of these 2 points, which one is A and which one is B? If I take A here and B here, then it is correct diagram. But if I take B here, A here, that will be a wrong diagram. Why? See, according to this diagram, because angle has to start from BP vector and at AP vector, which I told you just now, and direction is anti-clockwise because this angle is positive. This is anti-clockwise direction. But if I take B here and A here, then for angle to be pi by 4, the point P will have to move on this circle. whose center will be below x-axis. Why? If P is here, angle will be positive for this portion only. See, this is BP, this is AP. Angle should be moving from BP to AP vector, and it should be anti-clockwise, and amount should be pi by 4. This is anti-clockwise direction and angle is pi by 4. That is, if I take A here and B here, then the part of circle will be below. But because it is given that P is lying here on this circle, I will have to suppose this is the point B and this is the point A. That is, this is Z1 and Z2, because Z1 was a affix of A and Z2 was a affix of B. That is, this is minus alpha and this is minus beta. And to find these 2 points, simply putting y equal 0, I get x square plus 5x plus 4 equal 0. That is, x equal to minus 1 and minus 4. Therefore, minus alpha becomes minus 1 and minus beta becomes minus 4. That is, alpha equal to 1 and beta equal to 4. Hence, B and D are correct choices. According to the concept I just now told, this equation represents a part of circle, say this, and minus alpha minus beta are affix of endpoints of that part, and z is anywhere on this part, and the amount of this angle is pi by 4. Obviously, if this angle is pi by 4, angle at the center will be pi by 2, and if this is the point z0, then according to this, argument of z0 plus alpha upon z0 plus beta will be pi by 2, because the value of z0, which is the affix of center, that is minus pi by 2 plus 3 by 2 I. And the second thing is mod of z0 plus alpha upon z0 plus beta is 1, because mod of z0 plus alpha means mod of z0 minus alpha. That is, it is representing this distance, which is radius. Similarly, mod of this also represent radius, hence it is equal to r by r, hence it is 1. In this way, we have got the argument of this and modulus of this both, and we know that if modulus is r, argument is theta, the complex number is r into cos theta plus I sin theta. Keeping this thing in mind, z0 plus alpha upon z0 plus beta will be 1 into cos pi by 2 plus I sin pi by 2, and z0 is already known to us, that is minus 5 by 2 plus 3 by 2 I plus alpha upon minus 5 by 2 plus 3 by 2 I plus beta is equal to I. That is minus 5 by 2 plus alpha plus 3 by 2 I is equal to beta minus 5 by 2 I minus 3 by 2, because iota square is minus 1. comparing real part and imaginary part, we get the information that minus 5/2 plus alpha equal to minus 3/2 and 3/2 is equal to beta minus 5/2. That is alpha is 1 and beta is 4. Hence I can say B and D are correct.